Okay. So what does the central limit theorem say? The central limit theorem says basically this, that if we take a relatively large sample, and by relatively large I do mean that n is bigger than 30, that the sample means will approximate a normal distribution. That is in essence what the central limit theorem says. That if you take a relatively large sample, by relatively large I mean n is bigger than 30, the sample mean is normally distributed. Now, why is that important? It's important because we do not need to know the population distribution. Okay? We do not need to know the population distribution. I apologize. I'll make it a little bit bigger so people can see it. Okay? Now, what this basically says is this, that let's say you have 15 people, and all 15 people are finding the sample mean. So let's say I ask you to find the age of how old people are when they first drove a car. Now, I know some of you are going to go like this. Well, isn't that 16 for everybody? No. Some people driving cars, you know, like Barry. I mean, he grew up on a farm. He was probably like 8. All right? Some people live in like New York, and they may not drive a car till they're like 70. Just because they have mass transit, they just don't have to learn how to drive a car. So let's say you have 15 people all going out and finding out the average age people were when they first learned to drive a car. Now, all 15 people are going to get a different average. Let's call them X bar 1, X bar 2, X bar 3, so forth and so on, out to X bar 15. Now, I think you can all agree that these numbers probably aren't going to be the same for everybody. That this person may find the average age to be 14.2, this person may find it to be 17.3, this person may find it to be 16.5, so forth and so on. They're not going to be the same for everybody. I think we can all agree on that, right? And because they're not going to be the same, the question is, well, how close will they be? And the answer is, part of it depends on how big of a sample you take. Like, if you take samples of size, say, for example, if you take samples of size 10, that might produce wider results than you would get if you take a sample of size, say, for example, 40. That if you ask 40 people, if they ask 40 people, these people ask 40, so forth and so on, all the different people ask 40 people, those numbers ought to come in closer together than they would if you only asked 10. And 10 would be closer together than if you only asked 1. Okay, so that's the idea. What the central limit theorem says is that if you take a sufficiently large sample, and 40 is sufficiently large, that these means will ultimately form a normal distribution. And that's the essence behind the central limit theorem. That if you can take a large enough sample, that you stack these means up, that those means ultimately will produce a normal distribution. And that's a critical thing. And people will oftentimes say, well, I don't know why in the hell that's critical. I don't care. I'd go my whole life never need to know that. It is critical if you ever plan to use the z-score chart, which right now is the only chart you know how to use. So it's kind of important because you have to use the z-score chart, and that's the reason why you can use it. Now, there's a couple other things that are of interest to us. Number one, there are a few corollaries that you need to know. And that is simply this, that if you take the average of all these averages, so the average of the averages, so the averages of the X bars, that is equal to the average of the population. So I note that like this: mu x bar equals the average of the population. So in our case here, a couple corollaries. Number one, probably not how you spell corollary, but it'd be close enough. A couple corollaries. Number one, that the mean of the sample means is the mean of the population. Okay? Expressed in symbols, it would look something like this. That the mean of the sample means I don't know how to make that X bar. I used to know how to do that at some point in my life, but I don't remember how to do that. Anyway, that's supposed to be X bar. I don't know how to do that though. It's equal to the mean of the population. Okay? And additionally, that the standard deviation of the sample means is equal to the standard deviation of the population divided by the square root of n. So in symbols, that would look something like this. So in symbols, that would look something like this. Again, I don't know how to do the X bar thingy, but if I did, that would be X bar. There was a way to do that, and it's called overstrike or something or other, but I don't know where it's at. But the sigma X bar is equal to sigma divided by the square root of n. Okay? Now, a few other corollaries. Number one, if the population is normally distributed, then the sample means are normally distributed regardless of sample size. Okay. Okay. Any questions on that? That's in essence what you should have gone over last time, although I'm quite certain it's not. Okay.